So let's go over the problems for your practice test. Make sure you have a calculator ready. I'm going to clear it out. So here's our first problem. We're going to be solving using the quadratic formula. Okay. We're going to use p equals because we see the variable p over here. We have to label, and if you have pens of different colors, it might be useful. We're going to label our a, b, and our c. The variable that's squared is the a. How many p's? Well, there's just one of them. When in doubt, add that one in there. B and C is 4. So we're going to go P equals negative boy. Couldn't decide if he wanted to go to the radical party. The boy was squared, so he lost out on 4 awesome chicks. It's all over at 2 a.m. The bottom will be 16. 2 times 8 is 16. The top part, this stuff, you need to put that in a calculator. Okay, so I'm going to be entering that. Try to arrange myself. Let's see, we're going to put, let's clear it all. So again, on my calculator, I'm going to be putting, let me try to not make myself dizzy. Lid at night, negative. Oh, it's not negative. Clear all. 1 squared is just 1, in case you want to verify, just so that you know on the other ones how it looks when you enter 1 squared minus 4 times 8 times 4. Off to the side, it tells us it's negative 127, which before this unit would have been a problem because you can't have negatives inside of square roots and do normal stuff with it. That's why people came up with I. After break, we'll finally get to those videos I've been promising of some 3D colorful math stuff. Okay, when you see a negative in the square root, I need you to split it up into negative 1 times the positive version of the number over 16. During class, after we thought about it for a second, we realized 127 is prime. Okay, so you can't split that thing up. Why we put the negative 1? Because the square root of negative 1 goes outside. That's going to be your I. So your final answer is negative 1 plus or minus, which represents the two numbers, but just in a compact fashion. I, square root of 127, all over 16. These would be your two complex solutions that oops, late at night don't have coordination. Okay, so that quadratic up there has these complex solutions, meaning the parabola is not crossing the y-axis. So let's keep it going. We got a couple quadratics to do. Now we got this guy, same quadratic. This time we're solving for k. So k equals, a is this, b is 10 this time, c is also 10. So we're going to do negative boy, so the negative 10 plus or minus square root of 10 squared minus 4. I should have spaced things out better, but we'll work with it, times 4 for the a value, and c is 10. Okay, and this is under the square root. The bottom is 2 times a, which is 2 times 4. So on the bottom we get 8. Negative 10. Since I've chosen problems where I want you to practice taking out the I know that all the other stuff in blue inside the square root is going to get us a negative number inside the square root. So let's see how that looks on the calculator. We're going to go 10 squared minus 4 times 4 times 10. Okay, negative 60. By the way, I'm using Desmos.com backslash scientific for that. Okay. So negative 60 goes in here. That's equivalent to the previous step. We're going to break that up into negative 1 times the positive, or we know we have to break up that number. How do you get that number? Well, you can do 6 times 10. Most of you pick 6 times 10. Let's do that, because I want you to use whatever is going to come into your mind and to show you that any of the numbers will work. In class, I also mentioned that you could have used 4 times 15, which would have gotten you an answer a little bit quicker, but that's okay. This guy, the square root of negative 1, is I. Because if not, we stop and we're like, we can't do anything else. I. We split up the 6 into 2 times 3. 10 is 2 times 5. Okay, we're just chopping it up into little bite-sized pieces. We have a pair inside of a square root. What do we need to do? We keep one of them, right? We take them outside with the I. The other one gets eliminated. So let's go more to the left, because we're going to have to simplify some stuff. So we end up with negative 10 plus or minus 2i square root of our leftovers. The 3 and the 5 get put together because you can't break them apart and they have to stay in there. 15 all over the 8. Everything is an even number, so divide everything by 2. With our final answer being negative 5 plus or minus 1i. Here's 1i. You don't have to put the 1. It's not useful right now. All over 4. Here are my 2 complex solutions to this quadratic. 2 down. We got 17 to do. Now let's switch it up. Remember that that thing is called sigma, in case you're not understanding, because obviously that's not a common word. Not yet. You'll hear it a lot in college math stuff. That's sigma. That's a Greek letter S. We're going to use S sub n and this formula to figure out if I added the 7 numbers that are represented in that formula with the sigma, what would it add up to? I do not want you to plug in the 1. Oops. And 1 second. This guy should be the same letter. This is an I up here. It's not the same imaginary I. This is just regular variable kind of I. Okay. We could use this setup to get the 7 numbers and add them up that way. We don't want to do that because you're going to notice your answer is like really big. Okay. This guy is telling you that in our pattern for the series, we're multiplying by 6. That's called R, right? But the question is, well, what's a sub 1? Because you notice right here in the background, you need to know a sub 1. What's our starting number? Again, 1 in doubt, put the number 1. It's very useful for stuff. Most times in math books or on like Edmonton, like computer stuff, they won't write it just to save the space of writing a 1. And it's like, you should know that there's a 1 there, okay? But it's not obvious. Okay, we're going to use this guy now. So we put our fraction line. We're starting with the number 1. We know we have parentheses top and bottom, mainly to remind us what the different calculator steps are. Well, on the bottom, we're going to have 6 minus 1. Also on the top with the variable 7, which I get from here. And we can use the variable 7 because if you're counting from 1 to 7, that's 7 things. It would be different if there was a 0 down there. Okay, the bottom, I know that's 5. Okay. 1 times anything is just the other things. So we need the calculator for 6 to the 7th power. Okay, so let's see. Clear all. 6. Press my exponent button. 7th power minus 1 is that big old number that's right there. So my numerator is 279,935. I need to divide it by 5. So we're going to divide it by 5. Oops, that's not what I wanted to do. Let's see, how do I erase stuff? Okay, so we have the number. Is it in the right spot? Okay, calculator's being weird now. Okay, my answer there, divide that thing by 5 for me. Okay, and it would be that number. 55,987. If we added the 7 numbers from this geometric series starting at 1 and each time it's growing by multiplying by 6, it'd get up to that. I don't care what the numbers are, I just want to know what do you get when you add them up, which is this thing. Let's try another one of these. Okay, so we have the next two are set up the same. Notice on these we can notice what the a sub 1s are. Okay, so a sub 1 is here. We're adding 9 numbers because you see the 9 right there. Here's r. We set up our formula where we put the first number. We put the 2 sets of parentheses. Each time we are taking our r, we have a 2. We have a 2. We are subtracting 1, and excuse my, I don't know why my phone's getting unfocused and refocused and stuff. I'm not moving it that much. And we have a 9, okay? And the bottom is going to be 1. We do need that 4 right there. 2 to the 9th. I can't think of what 2 to the 9th is off the top of my head, so I'm going to go back to the calculator. To not distract you, I'll press clear all because those are from the previous problem. So we're going to go 2 to the 9th power is 512. I'm going to subtract 1 is 511, but I'm still going to do it on here because of the division that comes next. Okay, so we have 511, which would be up here. The dividing by 1 is not important. You're in math 3. You should know that if you divide by 1, you're not changing anything. If you're going to split up the money just with yourself, you keep all the money. What we do need is 511 times 4. Times 4, 20, 44 maybe? Oops, it didn't do what I wanted. It's not doing the order of operations how it should. Let's see. Backspace. What is it doing? Just hit enter. Clear all. Let's go 511. Calculator is good for a lot of things. I'm noticing which things it messes up on. 2044, as I thought. So these 9 numbers in this geometric series, in this pattern, if we start at 4, we multiply them by 2, we go up till we get to the 9th number. That's 2044. Next one. So we're going to go and draw our line. First number. This time we need to be careful because there's that negative number. I'm going to make my parentheses bigger because I'm going to add like double parentheses for a reason. Okay, bottom, it doesn't matter. -6 minus 1. We also are doing that on the top, the -1. But the -6 is the one that has the exponent. It has, the top says 8. Okay, I'm going to put 8 right there. So I'm going to have to be careful with that. -6 minus 1 is -7. If you're not comfortable with those negatives, put it into a calculator. The more practice you get, the smoother it will get, and your mind will remember how to combine those. That's something also that can work off to the side in the future. Okay, -6 to the 8th power is going to be a big old number. I know off the top of my head that that's going to be a positive because of how the exponents would pair off. Okay, so, and I'm going to make sure to put those parentheses because if you don't put the parentheses, you're going to get a different answer. -6, close the parentheses, exponent 8. Because I know it should have been a positive number. And I'm going to subtract 1 equals, okay, good. My question is on here. How do I make it? Okay, that's how I go to the next line, okay. So that's my top number. I'm going to put it right here in the parentheses. 1679 615. So comma goes there, so it's like more than 1,000,000. Okay. We need to multiply by 2 and then divide by -7. So let's multiply that by 2. Okay. And on here you would press answer, multiply by 2, divide by -7. Okay, so it's that number. -479,890. This is the sum of the 8 numbers. We don't need to know what the 8 numbers are. We just know that start at 2, and then we start multiplying by -6, so every other number is going to be a negative. Okay. Now we're going to do some word problems. I'll show you on the screen so you can see all the words. Here's my abbreviated notes for them. One's about Hema and her grandma and cousins and stuff. And one's about us. Let's see. You can see my scribbles up here. Okay. Hema's grandma taught her and 9 of her cousins, so that's 10 people, how to make pozole. Each cousin will teach 3 others. If this continues for 4 generations, how many people will know how to cook the family pozole? Okay. So again, important notes. We got Hema, the pozole, which is a soup thing, traditional and since ancient Mexican times, native heritage. 10 cousins got taught the recipe. Each of them is going to teach 3. Then those 3, for each of them, teach 3. 4 generations. You may not think so. This is the same as the previous problem. So we're adding a bunch of stuff. So we do that. There's 10 cousins to start with. We're multiplying that by 3. Oops, that is a very bad, weird 3 at almost midnight. 3. I like starting the bottom thing with a 1. 4 generations, so this is a 4. This would be n minus 1. Okay. Right there. I'm pausing because these variables should be matching. That's why. It'd usually be n minus 1, but it doesn't really matter. We keep in our heads that these two are matching. Okay. What we care about, we know the 10 and the 3 are going to go over here. 10 is where I start. We have 3 minus 1 on the top, 3 minus 1 on the bottom. We are going to put the 4 right there. And I'm going to leave the calculator stuff to you. What you should get is 400. So after 4 generations, if they were to finish this pattern with 10 of Hema's cousins knowing her grandma's recipe, there'd be 400 people who would know that recipe. Okay, things grow very quickly when it's a geometric series. Now let's talk about us. Again, let's see the problem over here. These were all the slides from our whiteboard.5. So Rodrigo, meaning me, where I teaches you 8 who are students in math. So the 8 of you in math 3. Each of you will teach 5 more students, and your 5 students will teach 5 more. If this continues for 6 generations, how many math descendants will I have? So let's set that thing up. So again, this is with our friend Sigma. I starts at 1. We're doing 6 generations. There's 8 of you right there. You guys are going to teach 5. I minus 1. Okay. That's just to help us see, the 8 and the 5 are the important. 8, 5, and the 6. The 6 is smaller, so it's going to be smaller on this side. We have 8 parentheses 5 minus 1 with the little 6 goes there. 5 minus 1. We'll work this one out because I don't remember what this answer is. 4, 8, and then big old number inside the parentheses up there just to make sure we do it right. Okay, let's go to the calculator. Let's hit clear. Clear all 5 to the 6th power minus 1. Here we have to press enter, so it goes to the next line and obeys me. 15, 6 to 4. Now we can do the other thing. By the way, I just noticed 8 divided by 4 is 2. So we only need to end up multiplying that thing by 2. So let's click on answer. Multiply by 2 equals, I would have 31,248 math descendants in 6 generations. You guys teach 5 other people how to do the stuff you're learning this year. Okay? Let's change it up. Now back to I and straight calculating. You need to use boxes. You need to be careful about combining like terms. And also we're going to keep in mind something that some of you may have not written down at any point. Oops. That was supposed to be like this. So it's because the notebook moves. Okay. Or I will. So remember, I is equal to the square root of -1. It bugged people, so they gave it a symbol. If we turn this knob like a dimmer, this is our second setting. That's why it's exponent 2. We're rotating 90 degrees each time. If you square both sides, well, the left is I squared. The right side would be -1. Now let's go to the third setting. I cubed, well, it'd be the opposite of that one that's up there, -I. And the fourth setting, we only have 4 settings. You can keep on turning this as much as you want and figure out what I to the 99 is or stuff like that. You need to do that for a mastery test, by the way. The ones that are sideways are equal to regular numbers because they're the real number axes. The ones in the vertical direction are the imaginary parts, okay? So key one is this will be referenced in this problem. Okay, let me change it up with the color. I've been writing in pink for a while. You see 2 sets of parentheses next to each other. That's your cue that Rodrigo's going to want to see a box just to make sure that you don't mess up and you have all 4 of your products. So 9 minus 2I, 9, is it plus? Yeah. Plus 2I. Those are called complex conjugates, by the way, when you have the plus and the minus. They're like a couple, opposites attract, and stuff cancels out. That's why we like them. 81, 18I, -18I. And again, using this box should be something you know how to do, like fairly easily. 4I squared. 4I squared, by the way, is -4 times -1, because that's what we said down here, what I squared is equal to. That's equal to 4. So that bottom right box is 4. Notice that these two cancel. They're opposites. So you just get 81 plus 4. So let's rewrite some stuff. 81 plus 4. That's the thing that we got with the 2 parentheses. And notice there's a negative that was there, right? That guy right there. And then we're going to get 9 minus 2I. This is equivalent to the previous thing. Well, that's 85. Just put a negative. The first parentheses is just there to show you that this is a complex number. And then you had some other ones back there. So we'll take them off just sort of to prompt your mind to knowing, oh, 9 minus 85 is equal to something. What is it? You either do it to the side, or you should know that you're going to end up doing 85 minus 9, but with your answer being a negative. 76. Oh, and the regular number should go first. The thing with the I later, like that. This is the real number part, the imaginary part. Altogether, the stuff inside this box is one complex number, because you have to have like an X and a Y. Okay, the 2 parts. Let's go to the next one. Same exact thing. I see 2 sets of parentheses next to each other. I know I need to FOIL that thing out. Best way to do it is the box. Why? Because if there was 3 things inside there, then you can make a bigger box. Okay, so we're going to get 36, 30I, -30I, negative 25i squared, which this is going to change into positive 25, okay? Again, these two cancel. That's why the problem was set up like that. So you're going to do 35 plus 25. Let's just write it down here so we can figure out what that is. 36, I mean. 50, 61. Okay. So 61 negative, 5i. This negative 61 has to combine with this positive 6. Again, I'm going to zoom out just so you can catch up because I know the thing I did to this side going to throw some of you off. Again, these cancel. These two are going to be regular integers. We're going to do 36 plus whatever this is, which is 25. 6 minus 61 is a negative number, which negative 5i goes after that. Let me see. I'm going to keep on saying it's late because it is. That's okay. Sometimes you need to stay up to finish stuff. Not too often. 56. And here's our complex number. Again, remember that the symbol for complex numbers, like the C, like the champion logo, like that. Technically not down, I just went down a little bit too far. Okay. The real number one is when you do this 2. Real numbers meaning the regular stuff, most of everything else that you knew in math is a real number. Now the stuff with the eyes or that go in pairs are part of the complex numbers. Okay, we have 17 to go, almost there, on number 10. So we have a quadratic, and the factors are these two. Remember that this represents two different complex numbers. What's the quadratic? Well, let's write those separately. It said the word factors. That means I can put things in parentheses. So 7 plus 2i, 7 minus 2i. What do you do when you have the two sets of parentheses? Hopefully your hand starts moving and starts making a box to make me happy. And again, if you do it this way, it's faster than you drawing the arrows, by the way. And very helpful for factoring purposes. Again, if you know that these two are going to cancel, you're allowed to skip them, but just to prove the point to you. Okay, the ones that have regular I are always going to cancel. Notice positive, negative. From here, negative 4i squared. You should be comfortable in you plugging in the rest of the steps and knowing why this changes to positive 4. If you don't know that, you're going to ask me the next time you see me in class. You're going to text me, Rodrigo, go over why is negative 4i squared equal to positive 4. And then negative 4 is going to combine with positive 49 to get 53. Okay. Oh, so the whole, 1 second. Oh, I messed up. I noticed something. If we have factors, I never put the x there. So I'm going to rewrite that. Let me skip ahead in my notebook. This is why you use things that you can erase, but oh well. Okay. So our parentheses should have an x. I'm going to make extra wide parentheses. Okay, let's look back. Okay, we are going to have a plus right here. 7 minus 2i and 7 plus 2i. Okay. Notice now there's 3 things. This is one of the reasons why you want to have the technique of using a box, because technically you would need a 3 by 3 because there are 3 things there. Even though complex numbers, sort of like what the name implies, they are more complicated because they're weird. But sometimes things that are more difficult in math are beneficial because some of what usually takes more steps, now we can cut corners and we're not cheating on it and participating in what math memes make fun of. Let me make sure I'm copying negative. This one's a positive. Because technically, to get our answer, we have to fill in those 9 boxes. Be careful and notice that some things are going to cancel. We could do that in this case. Yeah, let's do it in this case just so you can see it. And when we get more comfortable, this is going to be helpful for those who were in class. We started with some weird factoring ones where we started on the bottom of the big X instead of the top. This is the justification to why we can skip certain things. Okay, so this is 7x. This one is 2ix. This one is also 7x. This one is 7. 7 times 7 is 49. 7 times 2i is 14i. This is negative 2i times x is negative 2ix. Notice that this one right here, let me get a different pen so to point that out. This one is going to cancel with this one. I found some opposites, okay? We're going to do that for several of them. Coming up with this one. Usually that happens along the diagonals. Negative 2i times 7 is negative 14i. Got another opposite. And I'm dropping everything here in the living room. This one cancels with that one. Okay, the bottom right is negative 4i squared. That showed up on the last problem. That's positive 4. Okay. Notice none of the ones that are left over have i's. The i's have been canceled out. Let's write out what happens. So just doing the boxes, if you have something like this problem, again, this started as with them telling you, well, your factors are this. Okay. They started you off with that right there. Let me make sure that's what it said. And technically, they should have said that the zeros, not the factors, the zeros are this, because these things in the parentheses are your factors. So your zeros, your x-intercepts, which evidently, since it has an I, you can't really see the x-intercepts. Okay, and let's write out all the things that didn't get eliminated in the boxes. X squared. 7x plus 7x is 14x. Then we have 49 plus 4 is 53. Something that would be beneficial for me to do right now is to show you, okay, you see 3 things. Hopefully you know, I want you to do this thing. So 53 is your multiplication number, 14 is your addition number. Okay, this will help out for the last couple, especially if you weren't in class. Okay, usually I tell you what number multiplies to 53. Well, you're not going to find nothing, though it's going to work. What about 14? You know 10 plus 4 is 14. Let's do where you split it down the middle, 7 and 7. And leave a gap. There's a reason for this. 7 plus, okay, 7 and plus, we'll see, you're going to need something after the 7. Okay, because 7, what's 7 times 7? 7 times 7, 7 times 7 is 49, correct? Well, we need to get up to 53. How many more would that be? 53 minus 49, that's 4. We need 4 more. Cut this in half. So again, we want to add 4 in order to get to 53, because it says 53 on the top and it says it right there. Well, how do we do that? What we're going to do, we're going to put a negative 2i, and we're also going to multiply a positive 2i, because that makes negative 4i squared, which you can see that right there. It's not by coincidence, it all fits together, the math. That's the whole point of math, solving the thing, building the house so it doesn't fall down. And this is your 49 right here. Okay, this is working backwards. This is what the last one's going to be. So notice one time I'm going to use plus 2i right here. The other time I'm going to do minus 2i. And notice these things on the sides right here. That's what we see way up here, what I told you at the beginning of the problem. It's also the two things that show up after the x's right here. Okay, I'll try to zoom out. Notice the bottom right here is these two right here. The last problems will be, I give you this, it's weird, factor it, do something with i's on the side. But if you're straight multiplying, make the big old giant box, which this will be it's something that requires your attention and precision. If you do it just by arrows, you're gonna drive yourself crazy being able to keep track of them. So just make that box. Let's go back to my other ones. Okay, so as promised, we'll end the thing with factoring. This guy should look familiar. So that's the original problem. How do I do it? Well, square root. Last unit, it would have been, well, you can't do that. Well, now you can. X in one, x in the other. You know there's a minus in one, plus in the other. 7, 7. But this is the answer if it was x squared minus 49. It's not, so you need to put an I in either to make it work. Why? Because you can make a big old table and things will cancel out. Okay. So notice on the next one, you see the comparison. This is the difference of squares. This is the sum of squares. They're done exactly the same. Square root, square root. Put your parentheses like that. We're going to get x minus 9, and it's almost identical twin, x plus 9. The answers are going to look almost identical, but don't forget about yourself. Remember, if you're writing in like school kind of English, you would say you wouldn't say me. A lot of times you would say I did this, or I shall do this, or whatever. Okay, remember the I. And most of us are lucky to have both of our eyes and functioning. So we put an I right there, and we put a plus right here. Again, to point out how I know that, if you made a box, sooner or later you're going to do negative 9i times positive 9i, which would be negative 81i squared, which that equals positive 81. Okay, we did a bunch of them with an I squared. Reference the I wheel and bug me next time you see me. Okay, now for this bottom thing. Remember the thing that looks like the champion logo thing? That's complex numbers. When you write notes, any subject, do not write complete sentences unless they're requiring you to write complete sentences to turn it in. If you're hearing somebody talk, you come up with your own symbols, or maybe there's already official symbols. Might as well learn how to use them. Okay, what's the square root of 4? Well, that's 2. What's the square root of negative 64? Okay, for this thing I told you, you see a negative, do negative times the positive number, right? And then this changes into I, right? And then what's the square root of 64? You could break it up into 8 times 8. That's why 8's the answer. Okay. And also one thing to point out, we did get, let me think about this real quick. Yeah. So that would be 8i. Since we did, and so we'd get 8i plus 2. The regular order for a complex number is the thing without the I first, and then the other one. Okay. The thing why I was pausing is because when you take square roots, you notice that symbol with the plus and minus that showed up like on the last problem, on a couple problems ago. We could technically put it right here. I'm remembering what Edmentum is asking for on the test, even though I'm going to be sampling some other problems. You can just leave it as this. It could be this. The other answer would be that we would put that right there, and then you'd have 2 answers. Okay. Either or is fine. We'll know in context and I'll give you more insight more about it. Okay, that's 13. Another one with the translating the square roots. Okay, 9 is 3. And again, this one is not going to have a I, so that answer should go first. Might as well set it ourselves up. We'll just give the positive version of the answer. This one is going to go this way, where I split it up into -1 times 121. The answer to this guy is I. The answer to this one is 11. So 11I. 11I plus 3. And if you don't know the square roots, just put them in the calculator. Okay, now for factoring. I even put the big old X right there for you. What do? Well, we do 40. We do -12. Usually, my thought process would be like some of you who are finishing up Unit 2 would be, what are the numbers that multiply to 40? Put them on the sides. However, in Unit 3, when you're factoring and you have the hunch that I is going to show up, you need to start down here. Okay, start with that one. And we're going to split it evenly, meaning you're going to do -6 and -6. You have to put some stuff after the -6. So let's do some background stuff, because if you were to do -6 times -6, what's that? Well, that's 36. What number do I want? I want 40. How much more until 40? Well, most of you can handle. I believe all of you can. 4, or you would have done 40 minus 36 is 4. So I need to do some multiplication and add 4 more. How do I do that? Split up the 4 into 2. You're going to do -2i times +2i. Why does that work? Because that's 4i squared. And 4i squared is 4. Okay? So this is going to go on one side of the x. This is going to go on the other side. Meaning right here, -2i, +2i. Again, these are called complex conjugates. I'm going to write that one time for you. Complex conjugates. There's a word in Spanish called cónyuge, which refers to your spouse. You've heard like in legal movies or shows where there's the prisoner and they talk about conjugal visits, as visits by the spouse or the couple or whatever, because these form a couple. And notice they're opposite, because opposites attract each other. Okay, now these will go in parentheses, because again, the whole point is to be able to factor it. Make your parentheses a little bit wider. Complex numbers require more space, okay? Not as skinny as regular stuff. You have an X, you have an X, and then just write the stuff that's off to the sides. Both of them had the -6. One of them had the -2i. The other one had the +2i. Remember a couple problems ago when we made that giant 3x3 box? This is what we multiplied to get the top thing. Okay, things will cancel out. We didn't have to do the box because we trust that the pattern is going to work for us. And it does, because complex numbers are formatted nicely. 2 more to go. And then we'll see how it goes with me uploading it and sending it to you folks. Okay, 113. Don't start there. I already know I'm on Unit 3. If they're asking me to factor, there's going to be some i's in there. That 113 is a weird number. Okay, we're going to split it in half. 7 plus 7 is 14. But obviously 7 times 7 is not 113. So leave some space. 7 times 7, 49. I need to add something in order to get to 113. I don't know that one off the top of my head. Okay, and it's 12. I don't feel like doing it by hand right now. I could. Let's hit clear a couple times. 113 minus 49 equals 64. Okay, 64 should be a key kind of number that's nice and balanced. It's a perfect square. 64 is 8 times 8. but we can't just do regular 8s. We do one positive and one negative, each one with its I, because that would be negative 64i squared, which is equal to that. These, one at a time, are going to sit next to the 7s. So one negative, one positive, and then let's put our extra wide parentheses because it's not a polynomial, but we can call it that. Well, no, technically it is a polynomial. You can have polynomials with i's, so it's like you're having a trinomial in there, 3 terms. X, x, that's for the x squared, right? For the other thing, to get the 14, that's why there's a 7 and a 7. But 7 times 7 is not 113. That's why we need to add the stuff with the i's. Okay. Super advanced factoring. Don't personally remember seeing this. Those who missed class, I mentioned. I think I seen it maybe in calculus in high school, freshman year, Sac State, in 2005. So this guy right here, in case you're not recognizing, this is your answer. And you're noticing factory is an important skill to have. You chopping things up, noticing the patterns. Last one, we made it. 74, negative 10. This is your addition. This is where you start on the bottom because you know you have stuff with I. How? Negative 5 plus negative 5. Okay, we write notes to ourselves to see, okay, negative 5 times negative 5, that's 25, which is obviously way off from 74. We're going to do on the calculator this. Well, actually, I know what that is because this is almost like 75 cents. That'd be 50. But one less, 49. This is 49. Okay. This is going to be negative 7i, positive 7i, because that would be negative 49i squared, which is 49. Put negative 7i here, positive 7i here. And again, all your work is allowing you to retrace your steps in case we messed up. Notice even late at night, there was only that one time where I had to flip the pages. Maybe twice with some errors. Okay, and then we have extra wide parentheses. Who cares if you go over the red line? It's not English class. It's just there for show. We need to use every single little space of the paper. 1x there, 1x here. You split up the 10s in half. 10s in half. And then what was it? It was a 7. Okay, minus 7i plus 7i. And I hope that you seeing the problems from the practice test worked out are helpful. Again, you just upload whatever you're copying off this. You'll get that credit for that assignment. It'll allow you to test. If you actually want to go in well prepared for the test, you need to take it like a test. Have your notes to the side, but then you try to do the problems because they're going to be almost identical. Okay, see you guys soon.